If your production server goes down right now, how fast can you failover? If you set anything longer than 60 seconds, you're leaving money on the table and risking your SLA. Today I'll show you how AWS Elastic IPs can get you to near instant failover, and the 5 per region limit that trips up almost everyone.
Hey everyone, great to be back on the show.
Welcome back to the Network Ninja Cloudcast. Today we're diving into Elastic IP addresses, specifically the limits, how remapping actually works under the hood, and how to build bulletproof failover architectures. This is going to be practical stuff you can implement today.
So I've been working with EC2 instances, and I keep hearing about Elastic IPs, but honestly, I'm a little confused. Why can't I just use the public IP that AWS automatically assigns to my instance?
Great question, and this is exactly where people get burned. When AWS assigns a public IP automatically, that IP is ephemeral. Stop your instance, start it again. Boom! New IP address. Your DNS records are now pointing to nothing. Your customers get connection refused errors. Your monitoring goes haywire.
Oh no. So every time I restart for maintenance or updates, my IP changes?
Exactly. Now here's where Elastic IPs come in. Think of it like owning your phone number versus renting one. When you rent, the phone company can reassign it anytime. But when you own it, you can port that number to any phone you want. An Elastic IP is a static IPv4 address that you own within your AWS account. You can attach it to any EC2 instance, detach it, reattach it to a different instance, and the address never changes.
That makes sense. So the Elastic IP is like my permanent phone number that I can move between devices. But wait, does that analogy hold up technically? What's actually happening at the network level?
Good instinct to verify. Yes, it holds up well. Under the hood, AWS maintains a mapping in their network infrastructure. When traffic hits that Elastic IP, AWS's edge routers know which EC2 instance's network interface to forward it to. When you remap the EIP to a different instance, AWS updates that routing table entry. According to AWS documentation, this remapping typically completes in under 60 seconds, often much faster.
Okay, so for failover, I could have a standby instance ready and just remap the Elastic IP to it when my primary fails?
Exactly. And here's where it gets powerful. The remapping is API-driven, so you can automate it. You can use CloudWatch alarms to detect instance failure, trigger a Lambda function, and that Lambda calls the EC2 associate address API to remap your EIP to your standby instance. Your DNS doesn't change because the IP stays the same. No TTL propagation delays.
That sounds amazing. So what's the catch? You mentioned limits earlier.
Here's where people get surprised. AWS limits you to 5 Elastic IPs per region by default. That's a hard quota. You can request an increase through service quotas, but AWS wants justification because IPv4 addresses are genuinely scarce. We're talking about a finite pool of roughly 4.3 billion addresses globally, and they're running out.
Only 5? That seems really restrictive if I'm running multiple applications.
It forces good architecture decisions. Here's the thing, you shouldn't need an Elastic IP for every instance. Use a load balancer for most public-facing workloads. Application load balancers give you a stable DNS name and handle failover automatically across multiple instances. Reserve your Elastic IPs for specific use cases.
What are those specific use cases where I actually need an Elastic IP?
3 main scenarios. First, when a third party needs to whitelist your IP address. If you're calling a partner API that only allows specific source IPs, you need that static address. Second, for legacy applications that require a fixed IP for licensing or configuration. Third, and this is the big one, for failover architectures where you need sub-minute recovery and can't tolerate DNS propagation delays.
Got it. So for that failover scenario, walk me through exactly how I'd set this up.
Alright, here's a concrete architecture. You have 2 EC2 instances in the same availability zone or different AWSs for better resilience. Instance A is your primary. Instance B is your standby. You allocate one Elastic IP, let's say 52.44.123.100, and associate it with instance A. Your standby instance B is running, configured identically, maybe syncing data from your primary. You set up a CloudWatch alarm monitoring instance A's status checks. When that alarm triggers, it invokes a Lambda function that calls disassociate address to remove the EIP from instance A, then associate address to attach it to instance B.
What about the allow reassociation parameter I've seen in the documentation?
Sharp catch. When you call associate address, there's a Boolean parameter called allow reassociation. If set to true, and the EIP is already associated with another instance, AWS will automatically move it. If false, The API call fails if the EIP is already attached. For failover automation, you typically set this to true so the remapping happens in one API call without needing to disassociate first.
What's the biggest mistake people make with this setup?
Two big ones. First, people forget that while the EIP is detached, you get charged. AWS charges roughly $0.005 per hour for an unattached Elastic IP. Sounds tiny, but I've seen accounts with dozens of forgotten EIPs costing hundreds per month. Second mistake is not testing the failover. People set it up, assume it works, then discover during an actual outage that their Lambda doesn't have the right IAM permissions or their standby instance wasn't actually ready.
Let me make sure I've got this. Elastic IPs are static IPv4 addresses I own in my account. I can remap them between instances in under a minute via API. I get 5 per region by default. Use them for IP whitelisting, legacy apps, and fast failover, but use load balancers for everything else.
Perfect summary. One pro tip: if you're building failover across regions, remember that Elastic IPs are region-specific. You can't move an EIP from US East 1 to US West 2. For multi-region failover, you need Route 53 health checks and DNS-based failover instead.
That's really helpful. I'm going to go set up a test failover in my dev account today.
That's exactly what I want to hear. Test it before you need it. That's it for today's episode. If this helped clarify Elastic IPs for you, hit that like button and subscribe for more cloud networking deep dives.
And share this with your team if they're building anything that needs high availability.
Thanks for watching the Network Ninja Cloudcast. See you in the next one.